Hey folks, welcome to lecture 8.4. This is going to be looking at section 8.4, which is solution dosage calculations in medicine. And I have to say, I think this may be one of the most important sections in this whole semester. Yeah, we're going to be looking and focusing on dosage calculations. We're going to be looking at IV solutions, and flow rates and setting flow rates and lots of practice problems. Okay, so the plan is first we're going to be looking at administering solutions of oral medication, right? So volumes and concentrations. In part two, we're going to look at IV solutions, intravenous solutions, and flow rate. So we're going to introduce the concept of time into our uh, calculations. And then in part three, we'll just revisit all of this with more practice problems. As I said, and I've said before, uh, practicing solving problems is the best thing you can do to help yourself. So we're going to jump right into it and start looking at some problems given concentrations and some other piece of information. So number one, first thing, here's an example of NyQuil cold and flu. So this is an over-the-counter solution containing 4 active pharmaceutical ingredients, which would be the important solutes in this medicine. The concentration of acetaminophen is 21.7 milligrams per milliliter. The recommended dose for an adult is 15 milliliters every 6 hours. So how many milligrams of acetaminophen is the patient receiving if given the proper dose? Okay, and all these questions, by the way, we will introduce the question and then at any point, right, you should pause it and work through this on your own, and you can always come back and see the work here. Okay, so I want to first highlight the important pieces of information in the text of the question, right? And so the important pieces of information are the concentration and then the volume, the recommended dose of 15 milliliters, right? So to find the milligrams of acetaminophen given the volume, we can do a conversion, and that conversion, of course, will be based on the concentration, right? We want to convert from milliliters into milligrams, so we will write that conversion with milligrams on top. And we can start with the known quantity or the prescribed amount, which is 15 milliliters times 21.7 milligrams per milliliter of solution, remember? And we see milliliters cancels out. We're left with milligrams. And my calculator says 325.5. But remember, calculators don't know anything about significant figures, so we have to do this work for ourselves. We see 3 sig figs here and 3 here, and we also have to add the units. So the final answer would be 326 milligrams of acetaminophen. Okay, as always, right? Go back and watch it again, try it on your own. You have control over this. So I'm going to move on to the next question. And it's going to be very similar. A lot of questions like this. Amoxicillin is an antibiotic available as a suspension with a concentration of 250 milligrams per 5 milliliters, as you can see on the label here, right? 250 milligrams per 5 milliliters of amoxicillin. The 62.5 here would be the second active ingredient, the clavulinate potassium, right? I'm not sure if I'm saying that correctly, but that's okay. So 250 milligrams per 5 milliliters is the concentration of amoxicillin in this suspension. The doctor orders 600 milligrams of amoxicillin should be administered to your patient every 6 hours. What volume of suspension should you administer to your patient every 6 hours? And then we'll come back to the second question next. So once again, let's highlight the important parts of this text. And we have the fact that it's a suspension, and we have the concentration and the mass that we are wanting to give our patient. Okay, so this time we're going from the milligrams that we want into how many milliliters this should be. And so our concentration has, as written, milligrams over milliliter, but as always, we can flip it to give milliliters on top and milligrams on the bottom, which we need to do to convert into milligrams, right? So I will start over here. We have 600 milligrams times 5 milliliters per 250 milligrams. So milligram cancels away. We're left with milliliters, and you should give 12 milliliters. In fact, that's what my calculator says, but looking at significant figures, I would actually say 12.0 milliliters of this suspension. And why should the suspension be shaken? As you can see right here, it should be shaken because it's a suspension, right? Suspension, it means that the particles settle out. So when you pick this up, you would need to shake it. Okay, let's move on to another question. Here, augmentin. It's a similar amoxicillin clavulinate potassium suspension, but it's a little bit different concentrations, different constitution. So here, this would be the order would come in, give your patient augmentin 0.25 grams POQ8H. How much is needed for each dose? What does all that mean, and what should you do? So this label is similar to before, right? You can see some directions for mixing. If you want to reconstitute this, adding water to a total volume, it says shake it vigorously, and again add remaining water, shake again. Okay, so what does all this mean? We have 0.25 grams, and you should know that that is 250 milligrams, right? And then QH8 PO. So PO is by mouth, right, per oral, and Q8H is every 8 hours. It's Latin for every 8 hours. So 3 times a day, every 8 hours. That's just the abbreviations. And I've included a link down here to, yes, Wikipedia. It's a very useful site sometimes. Okay, how much is needed for each dose? That would be how much is needed means how many milliliters do we need? Okay, so the patient needs 250 milligrams. It takes 5 milliliters to get 125 milligrams. And so we would need 10 milliliters. And I think that looks good because the 5 has 1 sig fig, and so 10 has 1 sig fig. So 10 milliliters would be our answer. All right, that's going to wrap up part 1, right? Really just some examples. So we did an example. They all included concentration, right? And in the first example, we had a volume and we had to find the mass. The second question, we were given the mass and we had to find the volume. And in the third question here, we were given a shorthand order with grams and had to find the volume based on the label of the medicine. Okay. So when we come back for part two, we will talk about flow rate in IV solutions.